Time for another day of e-learning. But wait, where's Math Man? There he is, chasing down the students who don't do their e-learning.
Thought I'd start with our e-learning page and kind of talk through it, and so you know everything that you have to do for today. And so first thing is we have an online math counts competition, 4:30 today. And so be there or be square. And so if you've never competed with us, I can get you a username or password. Top 5 scores count, and here's the bracket. And so we're going against today a school in Denver, Colorado. And so we were the #1 seed in the tournament. Whoops, got the sound on my face. But we missed a couple since then, and we missed a couple of you. So you be there, and we won't miss anymore. And so we made it to the round of 32, the Sweet 16. Now we're in the Elite 8. And so this will be exciting. This afternoon, 4:30. It'll be a little nerve-wracking for me because I have no idea what's going on. And then all of a sudden I see scores pop up, and yeah, here we go. And so I'm excited, and so don't forget 4:30 today, okay? And so the next thing is on the, go back to what we got that. Make sure you fill in the attendance form today. Some of you fill it in a couple times because you forget, but just fill it in right away, and then take time, do it. Click on Wednesday, April 15th. Do you know that form tells me the exact time you fill it in? And I know who starts early. Like, kudos to Chris Dyer. She was the first one to start 8:58 on Monday. And then some people starting at 4 o'clock in the afternoon. And so we know who sleeps in. And so make sure that you fill in the attendance form. And so we're going to scroll down and find out what we're doing in class today. And so you have the notes. The homework is attached. Even though it's in the book, I have a handout. Makes it a lot easier. And this video thing's going to turn blue once I finish making the video. The warm-ups for this week are all found on Khan Academy. You can redo them. There's 6. You're only going to get 3 a week. You're not getting any new ones this week. Just do them all and have them done by Friday. And you can always redo them until you get 100%. Otherwise, on Friday, at the end of the day, you get what you get. Okay? And then we'll have new ones next week. For the logic problems, if you haven't turned in week 28, make sure you do, because we're on to week 29. And logic problems week 29 are right here. And next week, there's a Noetic Learning Math contest that you're going to get a username or password to sign in for. And it's 20 questions in 45 minutes. They'll actually give you 50 because it's online. But you're not supposed to use a calculator, and you just go through and solve these. And so here are some 8th grade questions. And so if I do like this problem right here, so you'll do them. What is the perimeter of the hexagon? Well, 5 times 5 is 5 squared, so that's 5. And 12 times 12 is 12 squared. And we all know our Pythagorean triples. This is a 5, 12, 13. And so then these are 13s. And then you're just finding the perimeter. And so these are nice problems that test your knowledge, and you got to find the perimeter of the whole shape. And so you go around the whole thing. And so try this, and then you just add them up. And you don't, 13 plus 12, that'd be 25, and this would be another 25, and 25 and 25 makes 50, and 50 plus 10, oh, I wonder what it is. And then you put it. On the online test, you won't put labels. You just type in the numerical answer. And there'll be a 2nd grade practice one next week too, just for you to practice typing in answers so no one messes up. And so we want to make sure. But we have a contest today at 4:30, and then this is getting us ready for next week. So I have these done. You don't have to take a picture of all these pages. You can just send an email, number 1 to 20, and then number them all, and then tell me what you think the answers are to all of them. And we'll give you probably half a point each, and you'll get 10 extra credit points this week. And so remember, 1,000 points is what we normally have. We're only going to have like 200 to 300. And so, yeah, maybe like 250. And so you need points. And so work on this stuff and get them done. We'll have new opportunities every week. Okay? And so before we get back to the lesson and the notes, we have a little commercial break. And here's the commercial break. Dun 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 dun. Commercial. Do you have trouble sending your homework to Mr. Nyson? When you take a picture of it, do sometimes your face end up in the assignment? Do sometimes you have extra lines all the way around? Well, if you do and you have the ability to have a smartphone, you can download the free app called Cam Scanner, and you can get a nice, crisp, clean assignment with no boundaries. And you can click Take Picture, and then instead of taking another picture, go back to that picture, and it says Add a Page. Then hit Add a Page, and you can take another picture, and it will be on the same document. And I can even print it back to back. And it just does a great job. So if you haven't tried that out, please, please do. Okay? And if that's not a possibility, then that's okay. But if you can, and so commercial's over, and I'll go sit in the corner. I'm so sad I have to sit down here in the corner. Okay, so we are going to talk about another type of transformation today. And so we talked about reflections, we played mini golf, we've done a lot of things with reflections, but we're going to review all the types of isometries. And so that's a big word, and you can look it up, but different types. And so one type of an isometry is a reflection. That's what this is. And so we have reflection. Some of you might be emailing me already, and it's not even 9 o'clock. That's a reflection, going from red to blue. Then we have another shape. Give me one. See if we have a name for anyone. Well, what's this one, Sarah? Well, that's a rotation. Great job. Or a turn. When we're littler, the teacher just says that's a turn. Of course, we're going to call it a rotation, just like what we've been doing the last couple days, or a flip, but we call it a reflection. This one here, where we just take the shape and we slide it, we used to call that a slide, but now we're going to call it a translation. A translation is a slide, or a glide. Your book likes to call it a glide. A glide, a slide, but they're all translations. But there are actually 4 basic types of isometries. If I look at the red shape, I can slide it, blue to red. How do you get from red to blue? I can flip it. How do you get from blue to red? I can turn it. But in this one, how would you get from blue to red? Well, I can't slide it. If I copied this here, that's pretty bad. But if I took this shape, obviously, I can't slide it to get this one. And I can't flip it. I'd flip this one. But wait! This is like a double. It's like a slide and then a flip. And so we'll call it a slide flip. Nah, you knew it couldn't be that easy. And so it's not going to be called a slide flip. It's going to be called a glide reflection. In every movement, and this is how computers and things can animate things, because I was going to call it a glide animation. It is a glide reflection. All movement can be one of these 4 basic isometries. To get a movement, you either turn something, or you flip something, or you slide something. Slide it, flip it, turn it, or glide reflect it. And that's the new one. I bet you didn't know that one was coming. And so we're going to talk about all these. Okay? So make sure you fill all that in and you got that. And so a translation, a slide, a translation glides all points the same distance in the same direction. And then we could call those slide lines or things. But all the glide lines will be parallel. They will all be parallel. And so if we look back up here at this translation, this point goes to this one. And that's what we call the glide line. It went right there. This point goes to this one. And that's the glide line. This point goes to this one. And that's the glide line. Now, usually we just take the vertices and do it. But there is a point here. And there is a point here. And it slides too. And notice how all of these are going the same distance in the same direction, and they're all parallel. And we're going to use all those ideas to talk about translations and talk about glide reflections. A translation is just a slide. Okay? And so we're going to do some of the problems that you would be expected to do and understand. And so we're going to take a point, and we'll just plot any old point. Doesn't matter where it is. I'll just put it right there. And it says a translation R maps P to P prime. So we're going to call this point P. And what's it going to do to the point? Well, it's going to take the point, which is xy, and it's going to move it to x plus 1, y minus 3. All that means is wherever x is, you're going to add 1. Well, when you're on the x-axis and you have an x value, adding 1 just means going to the right one. Slide to the right. Slide to the right. And so we're going to take this point and we're going to go to the right one. This means we are going to go y minus 3. That means we are going to go down 3 under the sea. We're going down 3. And so we were here, but now we're going to go a 1, a 2, a 3. And so my new point is right here. And this would be P prime. Now you got that point. Now that point, it says you're going to have translation S. Well, what's it going to do to the point? Well, it's going to take x minus 4. Well, x minus 4 means you're going to go this way 4. You're going to slide to the left. Slide to the left. And so we're going to go left 4. Then we're going to go down 3. And so here we are. We're down 3. And then here's my new point. Are you getting the point? And it's P double prime. Whoa. And so we had a translation that went from here to here. Then we had a translation that went from here to here. Now I want to know the overall translation that would have taken me from here to here. What would that have been? Well, if we look at this, to get here you would just go left 3, down 6. And so your answer would be left 3, down 6. And be x minus 3, y minus 6. Now, is there a way I could have gotten that without drawing a picture? When in doubt, draw it out. Well, if you look at these two, a slide to the right 1 and a slide to the left 4, what's negative 4 plus 1? Whoa! It's negative 3! That's wham! Amazing! And that is no joke. All I had to do was add those together. That's quite amazing. Look here, if we go down 3 and we go down 3 more, we're just going down 6. That's all I had to do? No joke. And so, Math Man takes care of those people. You don't have to worry about it. Okay? And so those are translations. Now we have what is called a glide reflection. And so we'll go over here, and maybe I'll put myself over in this corner. Oh, I got tired of sitting in that corner. And so we're going to plot this triangle. And this triangle, A, negative 3, 0. Plot that. Maybe I should change colors. I'll put in red so we can read it. Negative 3005, we'll put that up here. And then 4, 9, right? 4 up 9. It'd be really embarrassing if I plotted these points backwards. And so we have this triangle. And I know it's really skinny, and so we're going to look at that. There's that point. Here's this point. And there's another one, which really isn't drawn perfect, but we have that. Now it's going to say, what are you going to do with this triangle? The first thing you're going to do is you're going to glide it. You're going to slide it. Well, if x goes to x, that means it doesn't slide to the right. It just stays put. But then here, the y value, we're going to go -5. That means we are going to go down 5. And so this point right here is going to go down 5. Well, if that point goes down 5, then this point goes down 5. And then if that point goes down 5, this point goes down 5. Do you get the point? They're going down, 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 down. And so we're going down 5. Okay? And so you could draw the new triangle here. And so, and you could label A to A prime and B to B prime and C to C prime, like that, and that'd be your new triangle. But see, I don't like clicking it because it shifts it over. But then it shifts it back, so it's all good. But then it says reflected in the y-axis. Well, don't go across the wrong axis. I've done that before. The y-axis is this one. And so if I want to, here's the original image, A, B, C, easiest 1, 2, 3. And then this becomes A prime, B prime, C prime. We're going to take this new one and we're going to flip it. So this point, when you flip it in the y-axis, if it's in the mirror, you don't go anywhere. I'm stuck in the mirror. But if I'm on this side of the mirror, now I'm going to this side of the mirror. And if I'm on this side of the mirror, I am now going to this side of the mirror. And then this becomes the final image. The final image. And so, how does the original one, the red one, relate to the black one? It's not a turn. It's not a slide. It's not a flip. It's a slide and a flip. It's called a glide reflection. Okay? And so that's it. That is our notes. And so when you look at the homework tonight, here, I'll go back in this corner. Oh, I guess I've been bad. And so we'll sit in that corner. And so problem 1, it says a lot. It says in exercise 1 and 2, a translation T is described. For each, graph triangle ABC, then graph triangle A prime, B prime, C prime, and are they congruent? And then in color. Whoa, but I'm only going to see it in black and white, so it doesn't matter. But just like I use colors to help you, if you have colored pencils, use those to help you. And when you scan it, I'll see that you did that. But if you can't, that's okay. Draw the arrows from A to A prime, B to B prime, C to C prime. And you'll see that they are parallel and they're the same length. But what you want to do is draw the first one. So the first one is A is -2, 0. So label that A. And B is 0, 4, and label that 4. Or label it B. And then C is 3, -1. Label that C. And then label it A, B, C. And then it wants you to go x -2. So that's a slide to the... Jacob, to the left, to the left, to the left. And so what you're going to do is you're going to make this point, and you're going to slide it to the left, and you're going to slide it to the left. But don't do that yet, because what's going to happen to the y's, Morgan? Y plus 6. Oh, it's going to rise. Go up 6. Morgan, you're so wise. And so we're going to go left 2. So this point's going to go left 2, up 6. Then this point's going to go left 2, up 6. And then this point's going to go left 2, up 6. And then you're going to draw the new one. And then your new triangle, you can use a straight edge, is going to look like this. Now, are those triangles the same? is a translation, an isometry. Does it preserve distance? Does it preserve the shape? Yes, it's the same area. And then when they say draw in the glide lines, your glide lines, I guess I should change colors. Your glide lines would be this: A to A prime, B to B prime, C to C prime. Are those all the same length? And this gets into vectors. We got to do those before the end of the year. And it also gets into they're all parallel and they're all the same distance. And so label, answer all the parts, put that on there, and do problem 1 and 2. Okay? Then, for problems 3 to 6, you can just, there's no pictures. You don't have to draw them. 7 and 8, do the same thing. It says draw the triangle. So for problem 7, the triangle is at 1, 0, it's at 4, 2, and then it is at 5, 6. Okay? And label that ABC. Now what it wants you to do is to slide them all up 4. And so you're going to slide them all up 4. 1, 2, 3, 4. I declare a thumb war. 1, 2, 3, 4. And then you draw the new one. And you have that. Then it says to flip it across the y-axis. Here is Mr. Y-axis. This is where your mirror goes. And then your flip points are the same distance from the mirror as your original one. Just like, remember, racing your finger when you brushed your teeth this morning before you got ready for school, dressing up, ready to go, and you race who can touch the mirror first, me or my reflection, and it's always a tie because we're always the same distance from the mirror. And so you plot that. And then graph the image and do that. And then do the same thing for 8. Okay? Then when you get to 9 to 14, you're going to go back and visit 7 and 8 and answer some questions about that. And then the cool thing, you will need your mirror for number 18. And then for 17. 17 says, what do you notice about when you connect? This is called a glide reflection. You take this shape right here, coloring that, and then we slide it. I got to get this. We slide it right to there. Well, then if you flip it across this line, then this shape got moved to this shape by a slide and a flip. This is called a glide reflection, going from here to here. And so the question is, we want to make a little discovery, and we're going to use this discovery in the hardest problem, problem 18. So you got to do this so you can get the discovery. And so it says to connect A to A prime. It says to connect B to B prime. It says to connect C to C prime. And hopefully they don't shift. Of course they did, because that's what happens when I draw straight lines. Then I got to fix them all when I click off the button. Little glitches. You can use your mirror by placing it perpendicular at a 90-degree angle to each of these segments we just drew. And if you map B prime on top of itself, you'll notice your mirror is right there. If you put the mirror so A goes on top of A prime, your mirror will be perpendicular and the midpoint will be right there. And if you put the mirror so C will go on top of C prime, the mirror will be at a perpendicular angle, line of reflection perpendicular to the segment, and the midpoint's right there. Well, this question says, what do you notice about all the midpoints of those segments? They all lie on the line of reflection. The line of reflection contains the midpoints of those segments. And so make sure you walk through and do all that. Well then, how in the world are you going to use that information for the last one? So the last one, I'll be in this corner now. And so problem 18 says, and this is a hard one, it says, copy the figure, which I've already done for you. And it says, use the result in 17, which we already just talked about. to figure out where the mirror line is. So I want to put this shape on top of this shape. They're congruent. Could I just turn it? No, because it'd be the wrong way. If I just turn this, watch this. If I just turn it, see it, are you impressed that I could do that? It's the wrong way. It's not a turn. And if I just slid this, that's not going to work. It's not a slide. It's not a turn. If I just flipped it, that's not going to get you that. Oh, that was pretty cool too. And so it's a slide and a flip. So this problem's asking, where would the mirror be? And so the first thing you have to do is you need to connect B to B prime. You need to connect A to A prime. You need to connect C to C prime. You need to draw those segments. You need to find the midpoints using your mirror with the skinny edge down. So when you mark it, you're actually under the mirror. If you use the fat edge, your midpoints will be off. Use the skinny edge and mark the midpoints. And when you mark the midpoints, they will all be collinear. And collinear means on the same line. Okay? And so we do that. Okay? And there's just one other thing. There's problem number 11 that says, which of the following properties are invariant? And if you look up, invariant, where's invariant? And if I just go to my dictionary, invariant says, never changing, or in mathematics, a function, quantity, or property which remains unchanged when a specified transformation is applied. So when you slide something, does it change it? And so that's what invariant means. And so in the word orientation means, is it in the same order, like right-handed, clockwise? So orientation means, like in this picture, the orientation is A to B to C. It goes clockwise. But in this one, it goes A prime, B prime to C prime. So that's counterclockwise. Clockwise became counterclockwise. So the orientation did not stay the same because I am holding up my left hand. Does it look like my left hand or right hand in the mirror? Whoa. Did the orientation stay the same? And so in a reflection, the orientation changes, but everything else stays the same. And so that will help you with problem 12. What does invariant mean? Well, guess what? You can just look it up. And that took me all of about 10 seconds to do. It would take longer to ask what invariant meant. Okay? And so get your homework done. We look forward to seeing it. I'm going to finish your grades. I got all pre-algebras in Power School. I got all algebras in Power School. Then I email everybody who's missing something. And so my goal today is to have all of yours done, and everything will be good to go. And the videos, I figured out how to save them now. I thought I needed QuickTime and everything, but all you have to do is hold on a Mac Shift Command 5, and it takes a video as easy as like a phone. And so hopefully everything's working out for you. We miss all of you, and email me, and look forward to seeing you this afternoon, 4:30, going against Denver, Colorado, and they're going to learn Northridge Middle School today. Okay, bye everybody. Once I figure out how to stop this.